So this was an early like sneak peek of one of the board which is designed by me. Okay. Hi guys. Okay, so nobody has game. It's okay, completely fine. My name is Sukandana, and this is a day 7 of Arduino Workshop for beginners for Sapthagiri College. And this is the last day of online classes. So today we will be not learning anything new. What we'll be doing, we will be learning and like recall each and everything whatever we have learned today till today from the day 1 of this last week from like on 5th, right? If I'm not wrong. No, 4th. Okay. Last week 4th Wednesday, the same day we started, and today we are closing up this session. And in the end throughout the session, the interaction was really great, and we all went together ups and downs. And yeah, it was it was a really nice tour. So till yesterday we made multiple projects, and today it's time to recap whatever we have done from the day 1 till today. Okay, by which you will be having that, what to say, what can I say, like you will be having that excitement with creative mindset, like what can we make out of it, what should we do, all those things, right? And then we can start with any physical, like we can take some things on hand and we can start working. So today I brought few of the boards, like example is Arduino Pro Mega, like Arduino Mega Pro, I mean basically it's Arduino Mega Pro. And the original Arduino, like not the original one, but yeah, this is the original Arduino Mega. This is bigger than my hand. And this is Arduino Nano. Okay, this is Arduino Nano, very small, like my one finger it comes, right? Then I have ESP. This is 8266. Example, if you have any application which needs Wi-Fi, so you can use this kind of boards. And I don't have Arduino Uno because I'm sorry, I don't have. So I have this thing, this B Nest. This you will not get in market because this is created by me from my company Bbotics. So, but if you can get an idea how does the Arduino Uno looks, because Arduino Uno also is of the same form factor only, same dimension. Okay, so this is how the Arduino Uno looks like, but it's in blue color. And Bbotics board will be basically in black color, but since like it's a prototype board, so we went through green color board. It's completely fine. Okay, so yep. So we will wait for a few more minutes. Like exactly after 9 minutes, we will start the class and we will be interactive. Okay. So let me know, guys. Do you have any doubts from till today? Because since it's the last time. Hello, Monica BS. How are you? So since today is our last class, I may or I may not meet you again. If luck is there, I might meet you offline, right? So any queries you have in your brain, let me know. We can discuss and we can try to come up with a solution out of it, and how can we make it, right? Okay, only one viewer. Hmm, no issues. So we will wait for more 8 minutes. Monica, do you have any doubts? Like, do you want to do something, any projects you want to make or something like that? Let me know. Like, you have any creative minds? Like, I want to do something like this. So, we can discuss, right? own PCB. Like, are you talking about B Nest? So yeah, this is the Bbotics B Nest, like Arduino. Like it's far better than Arduino. Why? Do you want to know all those things? Are you asking? Like you are asking about B Nest? Let me know. Yes? Okay. So let's start with the communication. Okay? Now, the same Arduino Uno also comes in the same form factor. Okay? Now, Arduino Uno has a chip of Atmega 328B, right? But this has ESP32. Okay? This is one of the biggest change. Like the entire microcontroller is different. And it can also run from 9 volts to 3.3 volt. Basically, it's meant focusing towards the 3.3 volt, but yeah, it can run like it can run smoothly in 5 volts also. Okay, then it has the normal Arduino Uno basically runs on like Arduino Uno has 16 GPIO pins, right? 16 GPIO pins, but this one has 62 GPIO pins because we have a extender here which will extend more GPIO pins, and we have given more breakouts which you can connect, and there is no, like, you will be not facing any limitations to your fix your mind. Okay, and since it is using ESP32, you can connect Bluetooth and Wi-Fi, and you can do anything. Like you can connect PS5 with it, and you can play a game out of it. Or else you can connect to a server or router, and you can make an IoT system out of it. Right, and it has an onboard LED, RGB LED to, if you want to do something colorful, you can do. And if you see the back side, it has a SD card logger. Example, mm, if you want to store some data, right? You want to store some data which you which you want to fetch it in future. Getting my point? So you can keep it. You can put a SD card in the back side, right? You can put a SD card. By which what will happen? You can connect the SD card and you can start writing it. Okay. Now, if I go with another deeper specs, if I talk Arduino Uno, which we have, Arduino Uno has a memory of 1 KB. Also, and that is EROM, like ROM, and SRAM is 2 KB, right? But is this one? This one has 16 MB of RAM. No, not RAM actually. ROM, 16 MB of ROM. Like you can do a lot of thing out of it, right? You will be having no issues, right? Then Arduino Uno comes with a B-type cable. It has, like, if I don't know B-type wire, this is known as B-type cable, also known as printer cable. But it has USB-C, so you can connect with your phone cable also, right? All those things. Like in the same form factor, I am giving as much as possible inputs. Now, one of our biggest competitor is Bharatpay. They're also making the almost same thing, but yeah. Now we have a option of plug and play. Example, many of you people like in this class, you guys don't know how to like write a code, right? I have an option of drag and drop things where you can drag and drop the code and you can just upload it, which is a very easy thing which none of them are giving this in this point of time. So these are a few of the features which my board has. If you like it, do let me know. I will give it to you. Okay, okay. We will wait for more 3 minutes and then we start the class. Okay. Hmm. Today we have only 4 viewers. It's less. Never mind. It's okay. If I see the stats, like all the statistics. Good evening, Pratik. How are you? I'm fine. How are you? I hope you are doing great. Okay. Now if I see my content on the day one of the live classes, we had around 1,200 and 1,200 kind of students. Then two it was 400, day three it was 200, day four it was 100, day five also 100. Like I'm talking in round figures, okay, 100. Then day six was 96, and I don't know what will be today's count. It's decreasing day by day. Okay. Oh, let me put it in the group also. I have not put it in the group. Usually, I used to do that every day. Mm, okay. Still, we have 1 minute to go. I have. Okay. So, we still have 1 minute. So, Pratik, like, since you're watching, like, did you came up with, like, you are, till now, whatever you have learned, did anything came in your mind, say, I will make something like this, I will make something like that? And do you want to make it? Hi, Srimata. How are you? Sorry if I'm pronouncing it wrong, okay? Hi. Okay. So it's 7 o'clock exactly when we start our class. So should we start our class? Let me know, guys. And we will not do anything anything big, like not that big. We will be revising everything whatever we have learned till today, and we will be coming up with some project ideas. What can we do? And we'll revise all the coding part also. Okay, and then we'll close this session in online mode. And if possible, we will be having an offline mode also in future, right? And yesterday I didn't got time to send all of your names to Ramesh sir, who all have sent like their names and who all have done their works. So most probably after this session, I will be sending to the Ramesh sir, and then you might have a competition next month where you will be having a basic Arduino challenge where you can come up with your own creative minds and you can make some projects and show us, and the best one will get some prize, right? Okay. Hi Fatima, how are you? Hi Kiran. Okay. Okay. So let's start the class. Should we start the class? Okay. We should start the class. No other option. So, before I start the class, let me explain you like what all things we are going to do in today's class. We will be learning basically it's a recap class whatever we have done in the past 7 days in exploding one day. Okay, what all we have done, like we will learning what is Arduino, where it has been used, how it has been used, what are the applications, what board to select. Then we will learn with the coding part. Then we will be going with some few projects by which we will be we will again grind our brain in that coding part, right? And then we will be going with few theoretical parts, and that's how we'll close the session. Okay. Okay, so I will start. What is Arduino again? Oh, okay. So, if I start with what is Arduino, Arduino is basically a microcontroller. Like this, actually, this is a company. Okay, Arduino is a company who manufactures this kind of development boards for developer. Okay, for development community, they make like this kind of boards. Okay, now there are many boards. Arduino is an Italian-based company. Okay, and you can easily identify with this tintish green and blue color board, and it is in behind it will be written made in Italy. Okay, So these are the Arduino boards. Now, why the Arduino boards is so popular in the overall, like in the entire market? Why? Because like, if as far I know, before Arduino there was no microcontroller which was user friendly and developer friendly. Why? Because if I show you, like I will show you, better I will show you. Okay. Mm, yeah. So this is Arduino IDE. This is how the Arduino IDE looks like. Okay. Okay. This is a version 2 of the Arduino IDE. Like, see, the code writing, this is one of the project which I was doing earlier. So the code is so easy. Like you can, like it's a syntax, like you can various color combinations, so you can write simply. And if you go with the real life embedded coding, they're really confusing. If you go with like, if you want to run a single LED, you need to go with the port, which port you are selecting, then what is the pin mode, then you are writing all those things. Now if I want to run a LED to blink on and off, we are writing only four lines of code: on, delay, off, delay, right? But in embed C, it's not like this. You need to shift by like bits, okay, all those things. So that was the biggest one advantage which gave to all developer community, because people who don't know C language, like if I say honestly myself, I was not knowing C language before coming to this Arduino boards. I started my development in my seventh grade, and that time C language was like, oh, it used to go above my head. Like, what is Studio.io? What is printf? What is void as a int main? All these things. It used to confuse me. But because of Arduino seamless functions and all those things, it made me so easy to understand those things. If I feel it so easy, then it's actually very easy for all the developer communities who are coming and starting newly. Uh, Okay, so that's why the Arduino boards became very famous in the market. Then we have multiple Arduinos. If I show you a like if I just show you a like website, like if I go like Arduino.cc. This is the Arduino's real original website. If you go with their boards, like the number of boards they are, like it is available with them. Like we can just see Arduino Pro says we have so many boards we have. And not only Arduino, like there are many families. You can see these are all the Arduinos which is meant to achieve different types of like goals, what like based on your projects, right? Example, if I have a project where I need internet and very small place, I will be going with something like ESP or something like that. If I want a project where I want to communicate for very long range, like far away from each other, then I will go with LoRa modules. And if I have more computational power, I will go with STM modules. Okay, and I want many ports, like I'm making a robot, right? If I'm making a robot, then I want to make it move. So if I want to make it move, what I will be doing, I will be connecting multiple servos in multiple joints, right? So connecting multiple servos in multiple joints, like Arduino can't do, so we will be having a shield for that. Arduino has PWM pins. So based on each and every requirement, like the community has made one Arduino for each and every one. So this is how the Arduino Uno looks like. And if you want to make any games where you can interact with the computer, so there's another Arduino Leonardo, which is expensive also. So while buying, please see that you are spending your own money. Hmm. Then Arduino Mega is just the board which I showed you just now, right? Arduino Gamma, which comes with the onboard screen, and also there are multiple Arduinos. And China, China, like they are always ready to like clone anything in any second, right? If you just write randomly, if you write Arduino boards, just randomly, I have not mentioned any boards. So you can see there are hell lot of Arduino boards which are available in market, like from smaller form factor to bigger form factor, right? If you want to do AI related task, you have a Arduino. You want to do something related to basic Arduino. Like example, if I take an example of any normal general girl, what girls do they love to like they want to decorate themselves like with nice dress which can catch people's concentration, and like with proper makeup, right? Like generally girls are centric to fashion, right? So for that fashion we have Arduino Lilypad or is Arduino Gamma. Okay, these are the common boards which is been not Arduino, it is made by Adafruit company. I will show you here again. Adafruit fashion boards. Okay. So examples you can see, there is a girl here who has where Adafruit like they will be having fashion show like where they will be using this kind of lighting dress. Okay, I will try to show with the proper one. And they come up with lighting shoes where when they walk, it should show some lights. Then people come up with creative mindsets. Like you think and people will make it. So same thing, like example, this is one of the popular girl who makes all this kind of, see, she has connected a RGB LED on her shoes and she is playing around with it. Then she had made a necklace where she has a collar for the dog and for herself both, where it has a light which is glowing, and she has like some kind of, what to say, I don't know what is this called. So you can see, right? So each domain, like if you're into fashion, you have one kind of board which you can use. If you're into IoT, you have one board which you can use. And like every perspective, you have one kind of boards. So that's why we learned about Arduino. And Arduino, never think one thing, never think if you're perfect in Arduino you will get a job in market. Arduinos are good, Arduinos are best for development stage, prototyping stage, but it's not best. Like 80% time it is not recommended to go in industry level with the Arduino. Why? Because there are few tasks which are very complex, which are time constrained, which are errors. There should be proper error handling, all those things, which is generally not done by basic Arduinos, right? So if you have a very basic task like vending machine, which you see in your like example, if you're from Bangalore, you might have went to Nama like metro, right? Nama metro, that vending machines which are there, they are running on Arduino Uno. You know that if you ever see them opening the machine and they are loading the things, just go and have a sneak peek. You will identify Arduino Uno or Arduino Mega, one kind of boards. This kind of applications can go with Arduinos. But a large, if you are going with a company like Wipro, if you are going with Tomco, then PCS, L&T, all these big companies, Samsung R&D, these companies, they generally don't go with Arduino. They will use Arduino to test the things, like test the sensor, test the few components, whatever, all those things. But if you're going to production, if you're producing something which has been used in industry, basically we go with STM boards because they are more powerful, and they come with a specific, like if you are if you want to make a robot which the robotic arm should go and pick something, so it should only specific to do that, nothing else. Like example, Mahindra, they have a big machines in their factories to assemble their cars, right? All those things. For this kind of specific task, they have STM has a chip for that. STM is that, then you can go with VLSI. If you are a EC student, I'll recommend you go with VLSI and FPGA boards thoroughly and learn by heart. Like if this course is there in your curriculum, I will recommend please study it properly, because this will help you in your future while getting a job. Arduino can clear your basics, but it can't give you a high paying job. If you want to get a high paying job, so after learning your Arduino, like after you clear your basics, start moving into start putting one step ahead. Like after Arduino, you go with ESP boards. After ESP boards, you go with some STM boards. Then you can, after this microcontroller section got over, you can go with microprocessor like Raspberry Pi, where you will be playing around with Raspberry Pi because it's a computer. Then you have multiple boards based on your requirement. So once you start in this journey, you have a very huge market. Okay, those are this were the things where where we use the Arduinos. Okay, now you got to know why do we use Arduino and why do we use Arduino. Let me know, guys, if you've understood. And do you have any ideas which you want to make using Arduino? Let me know. Till then, I will rub this board and I will start explaining you. Like, let me get the duster. Yeah. So we on the day two of the class, what are the things we learned? We learned about what? We learned about sensors and actuators. What is sensors and what is actuators? That all things we learned. Then we learned about digital and analog signals. What is the difference between digital signals and analog signals? Then we learned about um, their examples basically. and we learned our basic functions and how to reduce the noise, like pull up and pull down resistors, because environment has a lot of noise, all those things, right? And with with this all small basics, we made multiple projects also, right? So we'll again start with the theory part. Okay, this one you might feel it little bit like bore, because it's a theory part, but don't get bored. I will try to keep it engaging and I will try to wrap it up quickly. Okay. So basically, we learned about like analog signal and digital signals. And if you remember that chart, how does it look like? If you make, I don't have a proper marker. It's not even visible. It's okay. I will take it in online ID, like online platform. No worries. Like the marker is not visible. Mm, okay. So if we first at the day two, we learn about analog and digital signals. If you see analog signals, if this is a time, this part is time, this is voltage. The digital signals will be basically square waves, and digital has only two values. What are the two values? If we see, the two values was one or zero. Why? Because computer can understand only ones or zeros, right? It can't understand anything more, right? This is only digital signals. And if you go with analog signals, if we have analog signal, again voltage, and if we have again time, the analog will be in a wavy format, and this is the normal format which entire world is covered with. We are covered with analog signals where we have waves like excuse me, in your physics you have learned, right, spectrum waves. So you will have the wave, based on the waves you are able to see this light, whatever you are seeing right now, the light which is being emitted by your computer screen is basically analog waves, which is which is falling on our eyes, and then we are able to process it. Everything runs on analog systems, but computer can't understand analog. That's why a computer can understand only ones and zeros. So we learned about how to convert analog to digital and all those things. Okay, now since we understood the range, like what is digital signal and analog signal can range between anywhere, like from 0 to 1023, or it can be more. Anything, it can be any between number, but digital signals will only always be 0 or 1, nothing else. It will not have anything else. Okay, this is analog and digital signals which we learned. Then we learned about what we learned. Yeah, sensors and actuators. Now again, sensor and actuators, if we see, sensors are the device which converts environmental signal, like environmental signal, like it can be temperature sensor, it can be humidity sensor, it can be pressure sensor, it can be motion detection sensor. All these are environmental factors, right? Converting any environmental data factors into a machine readable form where a machine can understand. It can be digital signals, it can be analog signals, anything which a machine can understand is basically known as sensor. So converting environmental, like what to say, environmental signals into machine readable form is known as sensors. And what is actuators? Converting any machine machine signals, like whatever machine is giving, like machine is giving 1 or 0, right? Whatever signals it is giving, convert it into any physical like physical motion. It can be like a motor, it can be a hydraulic pump, anything which can move or which can do something and which can impact the environment, not in a huge manner but in minute manner also. That is known as actuators. Just it's completely inverse of sensor, right? In sensor was like converting machine language into sorry, converting environmental data into machine language, and actuators like converting machine language into environmental scenarios, right? So I hope you understood this one also, right? Getting my point? Now, after this, we learned after all this analog and analog sensors, sorry, analog and sensors, not analog, sorry, actuators and sensors. Then we went through the PWM signals. Now, what is PWM? PWM is pulse width modulation. PWM, pulse width modulation. Now, electronic device generally can't convert any electrical signal into analog signal without without a converter. Okay, without a converter, it can't do those things. So, but it can mimic. Now, how? As I told on the day 2, day 3. About PWM, if you if you flash your close and open and close your eyes very rapidly, you will see very less things. But if you do it in slowly, you are able to see the highest brightness, right? The same way here also it goes. What it is doing based on the flickering, like this frequency, how fast you are doing or how slow you are doing, you are increasing or reducing the speed. How mm example, if this is a chart and if I want to do something very fast, I will on off very quickly, which will like reduce the speed, because since it is on and offing multiple times. And if I increase the cycle, and if I increase the range of on and off cycle, so you are using it in a high pitch. Okay, this PWM signals, like, which is basically a kind of mimicking your sorry, analog signals, but it's not exactly analog also. Okay, we learned about PWM signals. Then we learned pull up and pull down. Okay, pull up, pull up and pull down. Right? Pull down means always the default will be zero, and pull up means always the always the button will be positive. Right? So, example, if you have microcontroller MCU, okay, microcontroller unit, uh, if it is pull down, what will be the connection? Pull down means you are always connecting the input pin to the ground, by which, not directly to the ground, you will be having a resistor in between, by which you are eliminating all the noise. And you will be having a button on this side, a button on any sensor which will give on or off signal, okay, which will be connected to positive signal. Now whenever it gives any positive signal, you know, always electrons move towards the lowest resistivity. So since there is a resistor, instead of electrons moving directly from positive to negative, sorry, negative, it is going to microcontroller, right? Now if you don't put resistor, what will happen? Directly whatever current was coming from the IC, it will actually go to the ground, by which it will be never complete the circuit, and it will be a short circuit. You can damage the board. So always it's better to keep a fake load using a resistor. Okay, this was pull down, where whatever any noises, whatever it comes, it has been grounded every time. So default value will be always zero. Getting my point? Getting my point? Now if we go with pull up in microcontroller, what we do, if this is an input device, we will be connecting this with what? We'll be connecting this with resistor, and we'll connect it to the positive value. Okay, we connect to the positive value, and here we will be having a button or any sensor which will be connected to ground. Right? Khushi. Hi Kiran. Okay. So this is the same thing. Now what is happening here in microcontroller? Whatever default value happens, like anything, like it's on or it's off, anything happens, always electrons will be keep on going into that microcontroller. Since there is a load here, it will keep on going, by which microcontroller default value will be always 1. And the moment we turn off this switch, what happens? All the electrons rush from the positive end to the negative end. It doesn't go to microcontroller. Now why? As I told, microcontroller also have a little bit of resistivity, right? Make sure that the resistivity of the microcontroller should be not more than the resistor which you have used here, because else what it will not go there, it will go to microcontroller, right? So try to keep it a little bit less. So by which this is a default on state where you are always keeping it high. If anything whenever you connect a switch or any sensor, when it gets triggered, it transfers all the electrons from here to ground, by which a microcontroller will read 0. Okay, this is what we learned in pull up and pull down concept, right? These are the only things which we learned. Now we will go into the coding part. Okay, let's go into coding part. So till now you have any doubt, let me know guys. In theory part, like we have completed theory part, no more theory part, so you will not get bored. So let me know guys, did you understood the entire theory part? And before that, where can we use applications of Arduino? Let me know guys. So till then, people replies, I will delete it and I'll make it everything new. And I didn't thought many things in Arduino also. I will open Arduino boards. Arduino Uno pinouts. Okay. So no doubts. Should I consider there is no doubts? Let me know. Let me know, guys. Did you understood till now all the theory part and the application part? Where can we do use it? All those things. So since there is no reply, I assume people have understood and they'll want me to continue the class. Okay. Okay. We'll start with the like the things now. See, this is the Arduino Uno which we were using from this now till now, right? Hi, Cloudy. I remember you. You messaged me. Sorry, I didn't reply to you yesterday, like today. Okay. So this is an Arduino Uno. This is basically Arduino Uno looks like in a diagram format. Now, if you see closely, okay, if I show you closely, in your left hand side, like Arduino left hand side, if you see, there are power rails. This is the top part, which is a power rail. Okay, where we can see a 3.3 volt for 3.3 volt applications. Before that you have reset button. Whenever you press that reset button, we always get scared. Like example, if I show you my own board also, here we have two buttons, right? People get scared to like press anything. They will be like, if I press, the code will go, nothing like that. Reset button is basically whenever you press it, it will start the code from beginning. Like it will start the code from void setup, right? You remember, like first we should write void setup, then void loop, right? So if you, the moment you press on the reset button, what will happen? It will go into white setup, then white loop, all those things. Okay, this is the use of reset button. And why do we use reset button? By the name only you got to know. Reset means if something goes wrong, you will press the button and you will reset everything again, and it will start from the scratch. Okay, and 3.3 volt voltage, because as I told in yesterday's class and live yesterday's class also, there are many sensors which runs on 3.3 volt. They don't run in 5 volts. Okay, that is the thing. That's why we should always make sure that the sensor which you are using is compatible with which voltage. Then 5 volt, then we have two grounds and V in. Now V in is what? Example, if you see this Arduino board, example here is on Tinkercad. If I show you this Arduino board, you can see here is one jack and there is one more jack here. Okay, this is known as USB B, where you can see there is the USB is getting connected here, right? This is basically like a Arduino to program. We will use this jack to program the Arduino and to power supply the Arduino, right? And if you want to make it battery power, if you want to make it external power, so we use barrel jack also, where you connect it to till 12 volts. You can connect it here and you can start doing the things. But example, you are like you are lazy. You are like, I don't want to connect in USB also. I don't want to connect into barrel jack also. Then you have an option of V in, which we saw just now here. V in, we can also do the same thing where it will convert till 12 volts to 5 volts and 3.3 volt, and which will be powering and running the entire Arduino board without any issue. Okay, Th- that's why it is on a V in, like voltage in inside. Okay, then we can say analog pins. There are analog pins where A0 to A5, A1, so A0, A1, A2, A3, A4, A5, 6. Okay, so the analog pins. Why is it analog pins? Because it's this 6 pins comes with ADC. What is ADC? We learned in a previous class. ADC means analog to digital converter, right? These are the ADC things. Then if we come to the right side part, as I told, never touch the digital pin number 0 and 1, because these are the two pins which has been used commonly to program the Arduino. And if you block these two paths, the code will not go inside your Arduino, right? So make sure you always try to keep it empty only while programming. Specifically, if you are like really in shortage of connecting like pins, you don't have pins, that time you can go with 1 and 0, no issues. But while programming, you should remove that pins, by which it should not interrupt the compiler to take the code from this chip and give it to this microcontroller. Getting my point? Then, if I go again, this entire right hand section from top to bottom is completely digital signals, where it will be having general purpose input output, like input and output. It will do based on ones and zeros, right? And you can see the like the square, like wavy format. What is wavy format? Wavy format is a PWM signals, as we learned. Like it will be trying to mimic that analog signal. It will try to give that analog kind of vibes. Okay, this is PWM signals, and as you can see, Arduino's all the pin doesn't support PWM signals, like pin number 3, pin number 5, pin number 6, pin number 9, pin number 10, and pin number 11. These are the only pins which supports PWM signals. Okay, and rest all it goes A0 to A13, which is basically 14 pins, and you will have more two extra pins here, which is basically analog pin also. Okay, so this is how the entire wiring goes of Arduino. Now, whenever you come up with a project, always go to a data sheet. Just write pin out diagram of any project. You will get that project like this thing, the entire schematics. So go through it. What are the possibilities you can make it damage? What are the things you can do it out of it? What are the applications you want to do out of it? All those things you will get an idea, and based on that you can go with the boards, right? So always it's better to have a quick Google search before you go to buy any board for your specific task. Okay. Got it? Now, get back to the class, and this was an entire pinout explanation. What is like digital pins, what are analog pins, what are PWM pins, what are power rails. Okay, these are things we learned here. Right? Till now, any doubt you have, let me know guys. Do you have any doubt? So I assume there is no doubt. Hmm? Okay, we will go into the next part where we will be starting the coding. Okay, I'll go with to the Arduino IDE only because you will also do it in Arduino IDE only in future, right? So I hope you can see it. So basically, this is how the Arduino code starts. Okay, so this is how the Arduino code starts. We always learn there's void setup and void loop. What does void setup do? Void setup is always like to set up everything, whatever things have been required. It will make sure that everything is like falling into the place. Which pins we are using, for what purpose we are using. All those things we all generally mention in void setup, because in English term, generally English term, what is setup means? Setup means you're setting up the things before you start anything to do. Example, when you come to this class to study, you will make sure you will put a headphone, you will take a book, you will take a pen, and you will start watching the videos, right? When I take this class, I will make sure that I clean this room, and I will turn on the lights. I will take the internet connectivity, and I will make sure that whatever I will teach today, everything is there or not to show you guys or not, and all those things. Right? So basically, basic setup, right? So void setup here we learned about how to set up the things, which pins to be used, and void loop. Since I told you at the beginning of the classes, like what is void loop? Loop means it will keep on looping the same code, because if you go with a basic microcontroller and microprocessor, oh, this thing also we thought, like I thought it in like class one. Okay, microcontroller, I thought you that microcontroller is like a brainless creature, we, where you give the input like do this thing, it will keep on repeating the same thing throughout his life till it has the power supply. Okay, but microprocessor, like example, if a microcontroller, if I say it has an onboard chip, like it has an onboard memory, it has onboard RAM, it has ROM, all those things. Like everything is one package, and it is made to run a specific task by uploading the code in it. Right? Microprocessor, you can't upload any code in microprocessor. Like microprocessor is just a unit to control all the arithmetical logics. Okay, so that's why you always see microprocessor comes with a RAM separately, hard disk separately, ROM separately, keyboard, mouse, everything separately, because everything is not done by the microprocessor. Microprocessor job is to get the task and give the task to someone else. Okay, which can be anything. Where that there we use threading. Okay, so but microcontroller, as I told, microcontroller always goes into loops where it will keep on running the same thing, right? Then we learned about how to create a variable. First, data type. What should be data type? I can make it int, and I can give a name, which is also known as variable. So I will write LED, and I can make it as pin number 13. Okay. Now pin number 13. Why? Simply I have taken. Don't worry. And what is 13? 13 is an integer data type, right? So I am like, as I told, and I kept on telling till now. Humans are very bad in remembering numbers. We are very good in remembering names. So sometimes what we do, instead of calling the numbers, we will assign a name to that number. So whenever I call that name, I am actually meant to call that number. right? This is basically what variable is. And if you if you don't want to change this pin, like if the LED is 13, it should be 13 only, it should never change. So you can add const unst const before the integer value by which you are fixing it, like nobody should use it now. Okay, this is one of the way. There another way which is also known as define, hashtag define, 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 and you can put LED, and you can just give pin number 13. Okay, here you don't no need to use any is equal to or all those things. Okay, this is one of the approach which you can do. Okay, now I will go with the older version because since you are familiar with that. Then now in void setup we will be learning how to set up the pins, right? So I write pin mode M capital M mod. Why pin mode M is capital? Because it is a camel casing. Okay, to separate two different names. Okay, pin mode. What we are understanding by the pin mode, like you are putting a mode to that pin. It can be input, it can be output, anything. Right? This is a pin mode. Now pin mode, which pin you are trying to use? Okay, so I am telling that LED. I am going to go with LED, and what should the LED should do? Like now I got to know which pin I should work with, but I don't know what is the use of that pin. It is an input device or it's an output device. That thing we need to mention, right? So I'll write it as LED is an output device. I'll put output. Okay, output device. Okay, LED is an output device. We done it. We did it. Now if I want to blink it, now as I told, digital signals. How do we write a digital signal? Any idea? Basically, we write digital signal as digital write. And if I want to read something, I will write digital read. Same thing we did with our analog also. Analog write, analog read, all those things. Okay. Now, if I want to turn on an LED, what I'll do? Digital write, because I'm writing the thing. Okay. DIGITL, digital write. Okay. WRITL. Okay. Digital write, again digital write comes with two parameters. What is which pin I should write, on which pin I should write? I will tell, like you write in pin number LED. The LED, what I am referring LED, LED is pin number 13, right? So I am taking bro, take like if they take a digital write, will be having a LED. Like which pin to control and what to control. On or off. Anyone. On or off. Anything else. Nothing else. Okay, and instead of one, Arduino people likes to write high HIGH high, but I will recommend to go with one because you will be able to remember things. And then if you want to make the entire code stop, what will you do? If I want to make the entire code stop, I will be going with delay function, delay function, where we will be having 1000 ms as I told. 1000 ms means 100,000 milliseconds is equal to 1 second. Okay, when the crystal keeps on beating for around like 1000 milliseconds, then computer counts it as a 1 millisecond, all those things. Okay, so we have used delay, but I will recommend you in a real life application or in industry if you're going to going for a job next day. So make sure that don't use delay, guys, because delays are not that reliable, because of that delay function you are turning off everything, like every other task has been on hold. So better alternative will be RTOS, okay, real-time operating system RTOS. Then you have, I'm not able to recall right now. Millis, yeah, that was the same thing which I used for my satellite. Okay, Millis, got it. So you can use that kind of algorithms to not make your existing code to stop till that code gets over, right? So again, if I want to detail write, yeah, detail write, where LED is 0. Now, what will happen the moment LED is on? It will off for 1 second. Then LED will be off and on again. Like it will not even see that it's off. It will keep on running. So we'll put a delay again. Delay. Not yeah, delay. Delay of 1000 seconds. Okay. Getting my point? So in this way, you are like turn on the LED, then keep it on for 1000 seconds, then turn off the LED and keep it that for 1000 seconds. In that way, getting my point? Did you understood pin mode, wide setup, integer, loop, digital, right? Let me know, guys. If you are stuck in any of the Arduino part, like any of the coding part, let me know. No doubts? Okay. Wait. Okay, I assume there's no doubts. Mhm. Okay, then we after digital write, like in digital write, what we learned? One or zero. If you are reading something, you always expect it as one or zero. But analog is not like that. Analog has a wide range. Example, in that day we did a potentiometer thing where it was giving a value from what? Value from 0 to 1023, right? But Arduino can't understand that much because PWM signals go still to 55. So we scaled it down for the real value, right? All those things we learned. So I'll put a potentiometer also. C1 is to const in pot, and pot is connected to which pin? Let me see. Uh, Okay, leave. I'm not getting it. Leave. So pot, I'll connect to pin number 11 because it has PWM signals. Okay. Now the pot is also what? Pot is an input device or output device? It's an input device, right? So again, pin mode pot. It's input or output device, guys. It's an input device, right? Got it? Now we will be doing analog read and write things. Okay. Now, if I want to read a signal from that raspberry, as a not from that potentiometer, what I will write? I will take a variable int I is no, not I, like vote. Int vote is equal to, then I need to read it, right? For reading, what we will be using? We will be using analog write or analog read. Sorry, analog read we will be hiring to read all those analog signals and try to find out all the errors and all those things. Okay, so here also digital digital, not digital, it's analog, right? Yeah. It's an analog read, and which pin you are reading, you should tell, right? So pot. You are doing with a pot. Now, when you are doing with a pot, the issue which you saw was it was like from 0 to 1025, which is like way beyond the limit which it has, like the 255. So you can't use it in that much flexible way. Okay. So still we will try to reduce the range, how to reduce that much big number into smaller pace, which you have done in your where? Mm, statistics class. Okay, then I'll take another int r is equal I'll take int r is equal to map, which will open a map, then it will be taking which variable you want to do. So I will tell vote. Yeah, vote, then what is the like minimum value which you are having now? You can tell it no 0, and the what is the maximum like what is the maximum water you use in a month? It will be like 80. I don't know. No, wait. Soil sensor was giving 1000. Sorry, potentiometer was giving 1023. Right. This was the old range. Now we want a new range. New range will be to 0 to 255. Okay, 0 comma 255. Okay, getting my point. So what we did, we scaled down that much of big garbage well, which we were not required, into a smaller form factor using mapping function. This is the same thing we will be doing in our like normal day-to-day life also. Okay. So then after that we learned about how to print. Now if you want to debug something, Arduino works on multiple comp ports. If you see the bottom here, it is ESP things, all these things are written, but I will try to explain you to in easy format. Any doubts, guys? No, right? Okay. So we learned about analog and we learned about mapping function, right? And based on that, we'll be keep on doing some tasks, other tasks. you can put a if condition where if it is this much then do this, if it is this much then increase the resistivity, if LDR is detecting more like sun, turn off the home lights. All this basically these are the things which can be done using all these basic functions. Then we learned to make piano, you remember guys? So for piano we took five girls and we told them, no, not five girls, sorry, what I'm saying, that is another project. Here also one team did the same thing. Hmm. So they also made their project. It was a nice one. I will share the photo with you guys once they make once they send me the photo. So here also in online class also we many of you made a piano, online piano using Tinkercad, where based on the when we keep on clicking, it will be like make us different tune. So what for tune what we use tone function, right? Tu any tone. Then in this tone function, we took which pin we are going with. See, it is giving all this like a hint, like what are the things which can be done here, right? These are the things which will helpful for us. Okay, so it is telling which pin to use. I will tell like some buzzer pin which supports PWM pin and what is the frequency, like how much high or how much low I want. So I will go with 4000 or something like that. Then for how long I need, you can see like here only you can see pin, frequency and duration. Okay, so duration like again it is in milliseconds, so you can go with any milliseconds, it's completely fine. Okay, so these are the few things where which are things we learned here and we made, and then we learned how to Google search and make our projects get done. Example, if you want to make a if you want to make a project using ultrasonic sensor, how to do that, that all things we learned. Then we learned about LCDs, we learned about all those randomly small things here and there. Okay, I will go with some basic code and I will show you and I will check that did you like I will try to explain you the real life applications like project which has been done and how complex does it look like. Okay, I will go with some basic senses only. Mm, okay, DH, so TDS. Okay, is it TDS? TDS means to identify the amount of debris there in the water. Okay, so here we started a serial communication. Okay, you can see serial communication has been started. Then we are randomly generating an analog value. Why? I don't know why they are doing this. Okay, then it has taken some millis. Okay, now this is a little bit complex. I will not show you this one. Let it be. Okay, this is how done. We did some projects using Tinkercad, and we made some fun projects. So let me know, did you understood till now whatever the what are the codes? Did you understood the coding part? Did you understood the connections, how what to do all those things and how to use applications? Also, did you understood guys? Let me know. Till then, I will find a booklet of this one which I was also having. Arduino. Uh, Arduino project books. So yeah, this PDF is also good, not that bad, but yeah, it's of no like it's too much. You will be like it will go above your. Oh no, it has a quite decent amount of projects. Okay, I will send you this one in a group. You can go through it. Okay, I will send it now only. And if you want to go with basic coding part, which I did, Arduino 101 it was, which is a very old book. I don't know it has been revised or not. Okay. Um, no. Okay, the PDF which I have sent you earlier, that is only good. You can go through it, no issues. And example, if you have a issue like you are not that much great with the C language or any other programming language, you can go to w3school.com, like W3 School. I hope many of you know this. Okay, example, if you open a w3school.com, what will happen? Like you can select any of the programming language whichever you want to learn. Example, I want to learn C language because since my C is weak, I click on C and I will start learning here. Right, you can see it. So it's like it told, and it will give an explanation why we use like this. So this is a just introduction. Here we will be learning a syntax, how to use all those things, right? So you can start learning C language from here. It's really great, and it will be easy because and after every task, no, you will be having small test, basic test which you can keep on doing and you can keep on increasing yourself. I'll never recommend anyone to go with YouTube videos like the people keeps on commenting me and messaging me like, bro or sir, can you send me a YouTube video which I can refer and learn? Going through videos and learning is a really boring task. Why? Because you get not boring task actually. You get distracted very easily because when you are reading when you are in the full screen mode, you are studying, right? The moment you are studying, you will see them some new videos has came and like, "Oh, can I see this, can I see that?" If it is not in full screen mode, right? And again you need you tilt your phone, all those things, and you we genuinely and gradually we keep losing interest because we are just seeing the thing, we are not doing anything. So if you go through website, you need to read because you need to put your efforts. In YouTube, your work is to listen, but in if you're like going through websites, your work is to read and understand the things, right? Because you are putting your efforts. Everything is not spoon fed to you, by which it will keep you active also, and you will be able to grab quickly also. And still, if you have doubt, the small doubts which you have, you can always go to YouTube and you can search it out. Because when you want to get the things done quickly, that time it helps a lot. Okay, now here there are multiple languages. You can go with any of the languages and you can start with your journey. Okay, so I showed you the Arduino coding or like Arduino part also, that how does the Arduino part looks like and all those things. Okay, and we learned we made many projects in Tinkercad. And if you go back, like it's a long time, we didn't went back only. Whenever we start, we just actually start with the Tinkercad, right? So we will just see what all circuit. Okay, I didn't save any of the circuits here. Oh, sad. Like, okay, I have a PIR trigger very like whenever there is a motion, it will trigger a pin. Okay, there is a gate here. Oh, okay. Let's see. We have temperature sensor. Based on the temperature sensor, how much is the temperature is going up and down. Based on that, we are changing. Today is hot. I will make the room light is yellow color. If it is cold, I will make it blue color. All the things. Let's see the coding part here. Okay, if you see the coding, LEDs, why LEDs? Because this is an RGB LED. This is an RGB LED, and red, blue, green. Three LEDs are connected to three resistors, and this is an analog pin, which is a temperature sensor. There are three output and one input. Then serial monitor to read the things whatever is there. And what we are doing, we are analog read. We are reading the things and we are converting by putting a basic formula. We are converting into Celsius and we are printing. Now what I told, if it is this Celsius, print like glow this LED. If it is this to this, glow this LED in that way. So we will test it. Candidate is blue in color right now. So I will try to increase it. It became red. I'll decrease it. Oh, shade became red. Green, the green which is a normal temperature, like everything is correct. You can get to know. Then again there's a yellow, like blue. There should be yellow color. No, I don't know why it is coming blue in color. Okay, RGB. Okay, yeah. Fair point. So here it is when it is exceeding, it is going to red. Okay, this is one of the basic thing where you can use temperature sensor to identify, and you can what you can do whenever the temperature is increasing of the room, turn on the fan. If it's going below this threshold, turn on the heaters. This kind of projects you can do, right? Then let me see what all projects I have more. Then we made a project of LED dancing, sequential LED dancing. This you guys also have done, if you guys remember, right? On day two of the class, this thing where we can like glue an LED in a pattern where I made you to learn how to glue one LED and you made come up with five LEDs. Remember that? So same thing here also. There's a pattern of going back and forth, back and forth. That's it. If you see the code, it's basically a for loop. Let's try to diagnose this code. What is written in this code? Okay. Mm, हाँ sorry guys for the interruption. Okay. Now see you can see here. As I told in that day's class, like instead of writing the pin like output and input multiple times, we can go with one shot only. Like here you have seen pins from pin 2 to pin 11. I have declared in in one pins only and count is 10. Okay, that is the different thing. Then here is like for void setup. By this we are setting all the pins as output. Then there is a for loop where it starts. I is 0, then is I count is 10, right? Is I is 1 is as a 0 is less than 10 is true. Then what will happen? It will turn on the light, that light for one like 100 milliseconds. It will turn off the light. Okay, then it will again it will go back. I became what? I became 1, right? Because here you can see the logic, right? I is equal to I plus 1, or else you can write I plus plus. Okay, there is another increment. So again when you will increment it once again, it will be like 1. Is it lower than 10? Yes, true. Again it will repeat the function and it will keep on repeating till it comes to 9. And in 10 it will not repeat. Why? Because 10 is less than 10. No, because they are equal, not like less than or something. So it will be false and it will come out of this loop, it will go to the next loop and it will again start. Okay, so I hope you got this part of the code also, right? I will take a screenshot and put it in the group by which you guys can also do. Okay. Mm, yep. So, a few codes which we learned, and this is how we like finished our entire class. Okay, where we started with the completely from beginning. Today's class was completely summarizing the things, why we use Arduino, what are the applications of the Arduino, why it is so popular. Then we learned basic theories of electronics. Then we learned basic like theory of CS part. Then we tried to integrate both of them, and we didn't make any projects today. We just reviewed the previous projects, whatever we have done, and we have came up with some application where we can use it. Okay, so that's how we come to the end of this entire workshop, where it was a great time with you guys from the day like on the same day of Wednesday in the last week, like 4th till 11th, and I really enjoyed to teach you guys, and I hope that you loved the entire session, and I was able to deliver the content as much as possible in a clear manner. And if you didn't understand all of my videos, I have made it public, so you can go back and you can go through any of the videos. And if you still didn't understood, you can DM me, we can start having a chat. For past few days I was really busy, so that's why I might have missed few of the people replying, but I have tried to reply majority of the people. Okay, so we can have a chat and we can come up with some new projects, right? And since you guys have done like you have spent 1 week, entire 1 week, and you have learned many things, so I expect to come up with a creative mindsets, and where Ramesh sir will be hosting a event where you guys can participate and come up with this kind of creative minds, and the best people will get some prizes. Yep, that will be notified you from Ramesh sir, so go and ask him. Okay, and if possible we might have a offline classes in future, where we will be doing like still now we did everything in simulator. We didn't did anything in hands-on experience. So example, if I show you, Okay. Like till now, whatever we have done, right? We have done in like simulators, like Tinkercad and all those things. So you can take this kind of boards, okay? This kind of boards, where as per your application and which applications you want to use. Based on that, or else you can use this board also, robotics board. Okay, so you can use this any kind of boards and come up with some project ideas which you want to make. Like there are few people who messaged me that they want to make a drone. So I will not recommend drone using Arduino. You can go with ESP because they are more faster and the things, because Arduino comes with low memory power. So you should make sure that what is your application, based on that you decide what to do. Okay, then few people came up with they want to make some hospital chair smart hospital chair where they want to go anywhere in the place just using a joystick. That we can do. A person came up with a project like he wants to make a like game controller. You remember the day when I was saying like using actuators, what people does, they use Arduino to make a real life simulator for it's a common game. Like it was, I don't remember the game name. It is like a PUBG only, where they have taken a gun, they have connected solenoids. What it does, whenever they try to shoot, solenoids keep on giving recoil effect by which the person gets hurt, by which they can feel that, and they will feel like they're into that game field and they're playing around with it. Okay, so that kind of process you can do. That kind of projects can be done using like basically your um main high power Arduinos, right? All those things. Getting my point? So, yep, that all things we can do. So let me know, guys, any more doubts, and we can close the session. Hmm. So that's how we came into the end of the session. Do you have something to say, and you can give me a feedback? How was my class till now? I'll be reading all of your chats. So which will give a little bit of memory because I didn't see any of you guys. So I don't know. So the only thing which I know is names and the people who have sent me the code are their roll numbers. That too I didn't remember properly. So it will be really good if we can chat right now because till this many days we were learning something new. Now it's time to make connections. You remember the day two of the class I introduced one of the guy, right? He came up with like how the startup runs and all those things. He is about to start a channel. I don't know. He will tell me. Okay. Mm, then yeah, now making connections are important because now after learning basic things, you might come up with an idea. You will make the idea. You will evaluate that idea. Okay, and never evaluate around your friends because you see, if I give an example, when you were small, when you used to break a toy and you used to take the motor and you used to connect with the battery, like you have seen the popular meme where it's like you in Instagram. I guess you all are using Instagram, right? So there's a Kannada meme, popular Kannada meme. You take a motor, you take a battery, connect it, and zui zui, they will say, right? So what we feel like if you are around your friends, they will be like, oh, this guy has done this. He has a big brain. All those things. But reality might be something else. If you go to the outer world is completely different. So always whatever idea like you have, always come up with that idea and go with the outer world and evaluate like is that your idea is worth it? Is people will use it? All those things. Understand from asking them. Okay. Then after evaluate, then how to start? Then you can hold a few people. Say example, if I talk example of Presidency University, here Ramesh sir was there to like as our backbone, where we used to like come up with multiple robots. We have made multiple robots till now. Okay, so Ramesh sir is always used to be helpful for us. They used to be like he used to tell us, okay, can you make this kind of things? We used to like, yeah, we can. Or else we come up with the idea, sir, we will be making this kind of robots. Can you fund us? So this one-to-one interaction helped us a lot. So you find a mentor who can support your ideas and who can fund your ideas because in initial stage everything is a huge issue of fund only, right? Example, if I show this board only, the board which I made, this one, till now I have spent 8,000 on this. to make this board. But if I go into production level, it will be less. I will be making it under 500 rupees, this kind of boards, and I can start selling it into the market. People can use it. There's a possibility you can also use it, right? So these are the things. So every idea needs a place to nurture. The incubators are always there to incubate and all those things. And if your product is really unique, you can patent it every time. So that all things you can ask with your college people, like how to do all this process. And if you're coming from with a business mindset, if you want to become a job giver, not a job seeker, the entire world is there for you. And you are in Bangalore. Bangalore is a like hub for all these things. So you will be having more exposures where you can do. Example, I was lucky enough to be in presidency. I was lucky enough to have Ramesh sir in my in this entire presidency lifespan where he helped us a lot. I got a mentor, proper mentor, and I was having a proper team of Vikasana where we made multiple roads, and which gave me a multiple exposure. Example, as I was saying, like the board which I have made here, I'm from, like, let me tell you my background. I'm a blockchain student and I'm in my fourth year right now. Like, I'm in my final years and I'm doing CSE. But the board completely designed by me and sorted by me, everything, which is a job of EC person. Generally, what we do, like, CSE person means they will do only CSE work. They will not go into other domain. EC people means they will do only EC, but they will like, bro, we are from EC domain, we don't understand code. Right. I came out of that. Like this environment gave me an exposure where I learned multiple things. I learned how to make PCBs. I learned how what are the circuits, basic resistor, transistor, all those things. These are not rocket science. They are very easy. Like if you just make a small like click, if it clicks in your brain, you can make anything. It doesn't matter how much is the CGPA, in which field are you, all those things, right? Example, I was having an interest in biology. So till today, mm, whatever what to say at beginning what are medical tools, like example I will say one of the project which I am making right now, where I want to make the people who can't walk or who can't move their hands use. I will be giving them an exoskeleton which that with that they can move their hand and legs, all those things, where I am tied up with the company and I'm making out that things. So these are the things. Okay. Okay, Ramesh sir, thank you. Thanks a lot to give me this platform to take classes for this many students. And okay, this is a small announcement from Ramesh sir. Like on 11th January, there will be a exhibition. Okay, in your college, there will be a project exhibition on 11th January. I hope you guys come up with a good projects there, and most probably I will try to come there to see your projects and evaluate in face to face. Okay, thanks a lot. Thanks, Monica. Thanks, Swati. Okay. So, should we end this session or you have any doubt? Okay. As I can see, there is no comments, so no doubts, I guess. But yeah, I will be in that group which the group which you guys have created. I will be in that group. We will be keep on having a one-to-one chat. You can DM me if you want. We can come up with the product, right? Okay. So have a great evening with a great what is it, innovative ideas. Keep buzzing. Okay. So myself, Sukranandana, signing off from as CEO of Bbotics. And thank you, Sapthagiri College, to give me this platform. And thank you, Ramesh sir, to give me again this platform to connect with all of the students of Sapthagiri. And I really loved to be a part of this entire journey. Thank you. Thanks a lot. And have a great evening. Bye bye.